episode of CMAF, we are going to create an computeless transcoding pipeline. No servers, not even serverless, computeless. Now, what on the earth is computeless? Let's find out. Welcome to CMAF. In this episode, we will understand what transcoding pipeline is, what is Computeless Paradigm, how computeless workflows can be built, and then combining all this knowledge, we will build an end-to-end computeless transcoding pipeline. I'm still your host Girish Nair, and this is CMAF, where I will simplify cloud for media and future technologies. Indian OTT platforms are creating buzz around the world because of the scale and challenges they face as well as solve daily. As digital video consumption is increasing globally, these solutions are becoming gold standards in international market. In this series, I will be covering some of the core concepts required to build an OTT platform, one among which is transcoding pipeline. Transcoding pipelines are the backbone of an OTT platform. For a captured video to reach the end user in right quality and user to have an enhanced video experience, transcoding pipeline has to process the video seamlessly. I covered the word transcoding pipeline in episode 1, where we did in manual transcoding of an MP4 file into CMAF. Now, Indian OTT platforms on an average process 200 to 300 hours of daily content, so manually processing them is not possible. That's where a transcoding pipeline comes into the picture. Once the video gets ingested into the CMS, till it is ready to be distributed, there are many steps involved. AWS supports you to have an end-to-end serverless transcoding pipeline. But even then, you need to have a compute, like a Lambda or a EC2 instance, to run your code for creating the transcode job, to store the status in database, make API calls to external parties, notify the components when certain events happen, etc. In today's episode, we are going to achieve all of these without a single compute in the pipeline. Yeah, that means we are going computeless. We are all aware about servers, right? Servers are just hardware placed in your on-premise, your home facilities, colo, etc. But when it became very difficult to manage servers, we kind of moved into VMs or virtual machines. They provide you a slice of the server isolated for your workload in a virtual environment. This made it easy to manage and use VMs at a larger scale. But then we started using cloud extensively. That's where we moved into cloud-native development paradigms called as serverless. Although it is called as serverless, but still there are servers underneath, right? But the servers are abstracted from you so that you're not managing any servers. Similarly, when I say computeless, it's got compute and servers, but they are just abstracted from you. You won't be writing any code, managing CPU or memory, or deploying your function into any sort of compute. You will be just orchestrating everything, and rest will be taken care for you by the workflow. Talking about workflows, we can't miss AWS Step Functions. AWS Step Function is a visual workflow service which provides you serverless orchestration for your modern applications. This helps developers to build distributed applications, automate processes, orchestrate microservices, and create data as well as machine learning pipelines. This orchestration service centrally manages a workflow by breaking it into multiple steps, adding flow logic, and tracking the inputs and output between these steps seamlessly. Some of the core features of AWS Step Functions are: it makes application development faster and more intuitive. You can define and manage the workflow of your application independently from your business logic. Making changes to one does not affect the other. Using AWS Step Functions, you can define your workflow as state machines. State machines transform complex code into easy-to-understand statements and diagrams. Using AWS Step Functions service integration, you can configure your step function workflow to call over 220 AWS services, which means you can run your code in AWS Lambda, ECS, EKS, or Fargate. You can update your database on an Amazon DynamoDB. You can send notifications using SNS or SQS. You can do analytics using Athena, Batch, Glue, or EMR. Or even you can run some machine learning notebooks on Amazon SageMaker. Now, there are some services which are not directly integrated with step functions. That's where we may have to leverage Amazon API Gateway and the Invoke API functionality supported by step functions. With AWS step functions, you only pay for each transition from one state to the next, which means even if you make the state function to wait for an year, there's no cost for that. This makes step functions cost effective as you scale from few executions to tens of millions of executions. Today's demo is going to cover a variety of concepts which may not be evident at this point of time. So please keep them in mind and use them in your projects. As mentioned earlier, if your service falls outside the list of services integrated with step function, you need some workaround. First important concept that will help us here is API Gateway Service Proxy. Any action that you achieve on AWS console is also exposed as a REST API. That is, you can make an HTTPS request to that and get your work done. AWS API Gateway Service Proxy help you to create a proxy for these REST APIs and simplify them before exposing to end user. In this demo, we can see how we leverage same to expose media convert APIs to the step functions. Second is service endpoints. Some AWS services have special endpoints via which a service accepts API requests. We are going to see same in the demo. One of the core concepts which will help you to build an workflow is ASL or Amazon State Language. Amazon State Language is a JSON-based structured language used to define a state machine. While creating a state machine, you may have to interact with complex JSON objects. You may have to manipulate as well as query them for the next steps. This is where our next concept will be useful, called as JSON path. JSON path provides the capability to select parts of the JSON structure, similar to how XPath expressions help you to select a node from your XML document. In our demo, we are going to use some advanced JSON path expression to query results from S3 and create the job exit. How are you going to make transcoding pipeline computeless? Now, we are going to use all the concepts that we learned just along with AWS Step Functions and build a transcoding pipeline out of that. On the right hand side, you can see a sample state machine. We are going to read the job template from an S3 bucket. We will use JSON path to query and manipulate this JSON and pass it to the next step, which is initiate transcoding. We will make an API call and check if the API call was successful. If it was not, we will notify a failure and send an SMS notification. But if the call was successful, we have to recheck the transcoding status after regular intervals. That's where you can see the loop happening. If the transcoding is completed, you will notify success, and even you can update the database. This demo covers most of the important concepts that we learned earlier. So, without wasting our time, let's jump into the demo. As usual, let's start with the AWS console. Let's begin the demo. So, let's go to AWS console and open Step Functions. On the landing page, let's create our first state machine. You can build a state machine using the workflow, but I would prefer code. All the code required to build this particular demo is available in this particular GitHub. The link is in the description. I will update the README so that you can follow the steps later. State machine's details are available in statemachine.asl.json. Let's copy the content and paste it in the code snippet of state machine. This state machine will have 8 states. State 1 is to read the job template from S3. State 2 is to initiate the transcoding. State 3 is to check if the call was successful or not. If the call was a failure, it will notify you and let you know the error message. If it was successful, it will wait for the transcoding to complete. And this step has 3 states. It will make an API call, check the status. If the status is completed, it will notify you the success, else it will wait in the loop. And in case if the job errors out, it will send you a notification with the error message. You can see all the states on the left hand side. The service used to transcode the job is AWS Elemental Media Convert, and State Machine don't have any integration with that. So we are going to use API gateway as a proxy to AWS Elemental Media Convert. Let's go state by state and see how this works. First state is to read the job template. This is basically a task which is going to access a resource which is S3 bucket. And the parameters has to be mentioned here, the bucket name and the key. So we need to have a bucket and a job template JSON. Sample job template is given in the GitHub. So let's take that. Let's copy the job template. Let's create a file called as new job template JSON and paste it here. Paste the entire content here. Now you need three things to submit a job. It's a job template ARN, a queue, and the role. Now we're using default job template and queue. So all you have to update is your region and your account number. So let me update same. Also, I have to update an role which is an AWS Elemental Media Convert role, which will allow Media Convert to access S3 bucket to get the MP4 files. All details regarding the what transcode was covered in the CMAF video. Please refer same for more details. Once all three details are updated, let's save the JSON file. Once the template is saved, let's upload the new job template to the S3 bucket. You can see new job template.json. Copy the bucket name and paste it in parameter bucket. Copy the key and paste it in key. This task will read the new job template JSON from the S3 bucket, and the JSON content will be available as a part of $.result in the upcoming states. Second state is initiate transcoding. This is again a task, but this time this is going to invoke an API gateway. As discussed earlier, we have to create an API gateway which is going to proxy the media convert so that we can have our transcoding job done. Let's go to API gateway and create a new API. We will use REST API because we need an AWS service integration. Let's take REST, create a new API, and let's name it as. Let's create the API. Inside the API, let's add a new action called as post. Select AWS service, select the region, select AWS service, select AWS Elemental Media Convert, which we need to proxy. Now AWS Media Convert has a special subdomains which need to be specified to use the endpoint. So let's see what those are. Open AWS Elemental Media Convert in a new console. Ensure that you are using Media Convert console in the same region as your API gateway. Go to account and you can see the subdomain required to proxy your API gateway. Let's copy it, paste it in subdomain. HTTP method is post. So let's click on post and then let's override the path. To get the path, you have to refer the documentation, but I will just paste it here. You have to create a role which will allow API gateway to submit jobs to media convert. I already created that, so I'm just pasting it and click on save. Ensure that you always keep the authentication as IAM so that no one can access these APIs from the internet. Let's create a resource. Let's create a resource to get the job status later. To get the job status of a job, you need to pass the ID as a parameter, and hence I'm giving ID in the curly braces. Let's create the resource. Getting a job status is a get request, so let's add a method called as get. Again, you have to do the exact same steps which we did earlier. So it's an AWS service, the region. This time it's get. One additional step that you have to do is to ensure that you have the parameter ID is passed as part of your call. To ensure the job IDs are passed as part of your path, you have to add a path parameter. Let's add. Once this is done, our API gateway things are done. Let's deploy this. Once it's deployed, ensure that you have this invoke URL. Just copy it. Let's go back to step functions and paste the same thing here. Now if you see, it is asking for the API endpoint. So our API endpoint is nothing but remove the HTTP protocol and cut the name of your stage, because you don't need the stage name here, and that's your endpoint. Your stage name should be pasted here. The request body is the JSON template read in the last file and the combination of the input that we provided. And we're just merging the input as well as the job template, creating this request body and sending it to media convert. The response from this particular API will be available in part of $.transjob. So that's the second state. The third stage is called successful. This is the third state. This particular state is going to check the HTTP status from your response body and go to the next step if it is successful. If it's a failure, it will notify you with the error message. This particular stage is going to wait till the transcode is done. So if you know your average transcoding time, you can keep it same, or if you can't, you can just keep it at some random number. I'm keeping it 1 minute because it's going to take somewhere between 1 to 2 minutes to complete the job. So I'm keeping it 1 minute, and the worst case, it will going to run this state twice. That's it. Next stage is where we are going to check the transcoding status. Again, this is why we created the second method in the API gateway, which was the get ID. So let's see how this works. Again, the same thing, we need the API gateway, and here we need the path as /ID. So I'm giving a path saying is /parenthesis, and then within state.format. This is going to format the slash brackets with the job ID. So in the end, this will be like something like /the job ID. The result of this particular state will be available in $.status. Next thing is to check the transcoding is completed or not. Once you get the response from the API gateway, this is going to check for the job status. If it is error, it will notify you with the failure message. If it is completed, it will say success. And if it's none of these, it will just go back to the wait till transcode and wait for another 60 seconds to recheck the status and complete the process. And notify success is nothing but notifying you. Now if you see, I have to put a topic SNS ARN in both modes. I have already created the roles. I'm using that. I'll just show you what exactly this role is. This role, we need 3 major permissions. One is this access S3 bucket to get your content, invoke API gateway to invoke API gateway is the proxy to media convert, and an SNS access to send you notifications. Things are done. Now you can start the execution. Click on start execution. You need an input file here. So let's go to the GitHub again and open state machine input JSON. Copy the input. You don't have to understand all the parameters. You need to change 2 things. One is your destination S3 folder and the input file. That's it. We are good to go. Let's start the execution. The execution is in progress, and you can see the execution has already started. Thus, the transcoding is completed and the output file has been uploaded to S3 bucket. We have completed an end-to-end transcoding pipeline with just using step functions. You can also choose to update the status into your DynamoDB just by using the state function, another new task. If you like the demo, please like, share and subscribe. In today's episode, we learned about transcoding pipeline. We understood what Computeless was and how to make a transcoding pipeline Computeless. We achieved same using AWS Step Functions and the core concepts that we learned today. Hope this was useful. Please let me know your feedback. Hey!